Okay, so this is the third part in a series of videos on Heroku architecture, Credential by example. The agenda and the links to the other videos are available through a Medium article with the same title. So picking up from where we left off on part two, where we essentially created a Hello World Heroku application, right? So we're going to now do sort of looking at that same example. We're just going to explore some core concepts. We're not going to write a lot of code, mostly just kind of using some tools to sort of explore these concepts, like, for example, regions, build packs, slugs, releases, stacks, dynos, and Dino Managers. So we'll go through each of those slowly as we go. So let me go ahead and close this down and switch to the project. So let me go in here. A little bigger. Okay. Documents, CD, let's see what it is, CD Heroku cert. Okay, clear. Okay, so the first concept, let me run a command first, and then we'll talk about our first concept called regions. Heroku regions. And what this is going to do, this is going to pull Heroku for all available regions, wherever these things are. So before we talk about regions, we're going to talk about runtimes. So you'll see there's two options here. There's common runtime or private spaces. So the distinction is common. These are one thing you need to think about these runtimes. Essentially, they're networks, like computer network, right? So the idea is there are common runtimes where your application can run in that are kind of a shared network across multiple customers. Now, there's firewalls and such, and we'll talk about that later. But there's basically one giant network, and there's two of them. There's one EU and one in US. Separately, there's a completely different concept called private spaces, where you as a company can create your own network called a private space, and then host them in one of these regions. So the relationship is runtimes are basically networks. There are two common ones, one in US and one in Europe. And then you have the ability to create your own private space and then store them in one of these regions. So that's essentially the main concept. Now by default, if I run the command here, this is going to look at the app that I have in place right now. And I'm going to pay attention to, there's a lot of detail on the screen. Let me just do this again. Okay, so this is basically my application, right? The name is somewhere here, Hello Cert Larkin Tucker. The key here is you notice that the region is US. So this basically means this is an app that's running in the common runtime in the US region. Okay, and by default, that's where it goes. Now you can set this region during application setup, and you can also move them later. But we're not going to go through those commands. Just understand the concept of a region and then this runtime environment. Okay, so that's it for regions and runtimes. The next concept is the whole build process and kind of just redoing that again and paying attention what's happening. Okay, so what I'm going to do here is first talk about build packs. So when we did, I'm actually going to do this. I think the best way of doing this is to actually make a code change, and we'll trigger a new build, and then we're kind of inspect the results. Okay, so let's do that. So I'm going to go into code. I'm going to change my hello world to like hello world 2. So I think I already have it up. So hello world 2. I'm going to save it, close it, get status, it is changed. So as a reminder, right, before you can push anything to Heroku and start a new build, you have to actually commit your code because Heroku operates at a commit level. So I'm going to add this commit -m version 2. Okay. So once this is done, okay, so right now I've got my local repository, right? I got my new commit. Okay, so then I do to push this to Heroku from last time and start this build process, I do Heroku, no, git push Heroku. In my case, I'm pushing the started branch because, again, you might not need to do this. You just need to push master. But I'm pushing my started branch up to master. And I'll let this run for a minute, and then we'll come back and inspect its output and kind of walk through what's going on here. This only takes about maybe 10 more seconds. Okay, we're almost done. And what we're going to do is we're going to walk through this and kind of dissect it a little bit. Okay, so this whole thing that just ran, where it started with remote, right? This is a process that's running on a Heroku that is starting with your source code, right? It downloads the source code, and it starts doing some activities on it. Okay, and we'll talk through those activities precisely. And that code, that environment that's doing this is called a build pack. It's basically like an operating system that loads up and then runs these scripts to basically create your Heroku application. So again, the concept here is build packs. Now there are actually different kind of build packs depending on what kind of code you're running on. So let me just bring up a web page here. So Heroku build packs. So build packs, you'll see essentially there's build packs for each different kinds of language, right? There's Ruby build packs, Node build packs, Clojure build packs, and so on. You can even create your own, or you can use third-party ones, but these are the ones supplied by Heroku themselves. So you'll notice early in the process it says Node.js app detected. So the way this works is that the first time you run a build, it actually, Heroku looks at your application or the source code and then detects what kind of build pack to use, if it can, and then it'll set that build pack going forward. So matter of fact, you step back for a second here to see that, what the current status is. If I just type in Heroku build packs, this is going to list the build packs for this particular application, and you can see it says it's detected Heroku Node.js. Okay. Now it turns out you can also have more than one. You can, so a couple things. One is when you create your first time, it auto detects it, sets it. You can later on, there's some command lines involving the Heroku build packs where you can change it after the fact, right? And you can even use multiple build packs. Say if you have a build that maybe you're building a Ruby app but depends on some Node code, Node application, and has to do some pre-compiling on Node. So you can actually have an ordered list of build packs. Okay. Again, this is just a Node application, straightforward. It auto-detected Heroku Node. Okay, so that's pretty much what build packs are, but then let's talk about what they do. In the end, what they do is they do a whole build process, which is kind of what we're scrolling through here, and the output of this build process is called a slug, which is basically, think of it as basically a bunch of files that kind of encapsulate everything this application needs to, from a source code or a build, from a code, like a file system perspective, what it needs to run. Okay, so let's kind of walk through what comprises a slug, and just by example. Okay, so the first thing, go back to the top of this thing. The first thing here is right here. The first part of this slug is basically download of the repository itself. So whatever is in that commit becomes part of the starting point of this slug. Okay, the next thing it does, and it happens right about here, it detects which version of the runtime environment it needs. In this case, it detected, well, we had actually set from package.json the 10.16.3. So basically, it downloads and installs that version of Node. So that's part of your slug. So there's your source code. You've got your basically runtime environment, right? Then, if you go down further, you will notice that it starts installing dependencies. It's going through your package, your package lock in this case, and it's installing its dependencies, right? It's both its development dependencies and its regular dependencies, right? And then that becomes part of your slug. Then, if I could find it, there is a post install step, right? So in our example, we actually had a build step. So that was the run, npm run build, and so that ran. And in this case, it's compiling the TypeScript and it's creating that dist folder. So that the compiled output becomes part of your slug. Okay. Now, one little bit of nuance here is that you notice that it actually does something called pruning your dev dependencies. So the idea is your dev dependencies are things that are only needed during the build process, right? That's the distinction between dependencies and dev dependencies in Node. And you'll notice it turns around and basically does an uninstall of all of the dev dependencies now because it doesn't need those anymore. So that's sort of the last step. So in the end, this summary of, and basically now you have your slug. Okay, so basically this point. So a slug consists of your source, your language runtime, your dependencies, but not your, in the end, does not include your development dependencies and your compiled output. Okay, and that's basically what you have here. Now, let's do one thing. I'm going to do one command here again. I'm going to do Heroku apps info. We'll look at one more line on this. We looked at just that one line, but you'll notice here these lines right here. So we looked at the region last time, right? Now you could also see that the repo was 133 kilobytes, but the slug is much larger. It's 20 megabytes. That's because the slug is more than just your source code. It's the runtime, it's all the compiled output, all your third-party dependencies, which are probably huge. Okay, so that's kind of walking through what a slug is. So slug is essentially, again, what is used to then, well, let's go to the next concept, actually. One just side note, completely kind of related. If you look in the repository, there's a git, let's see, vi cat.git ignore. So we talked about this last time, but this git ignore are things that in your local repository that don't get pushed to your remote repository. So for example, node modules locally and your distribution doesn't get pushed to GitHub, right? So, which is right. There are some edge cases where you may have things in your repository though that also don't really need to make their way to Heroku. Maybe documentation, things like that. So what that's about is there's another file that we can create. It's called .slugignore. It's much like gitignore. It has the same format exactly as a gitignore. And all that does is when Heroku pulls down your repository, the first thing it can do is if it sees a slugignore, it'll just prune those files out. So the idea is you don't want your slug file necessarily too large. Just saving on disk space. So you have an option to provide a slugignore. This project doesn't have it, but it's something that exists. Okay, so let's scroll back up. You'll notice, let me go back if I can find that output, right? We're switching to the next concept, which is called releases. Okay, so we talked about slugs, and now we're talking about releases. And so you can see there's a version number, release version 8. Okay, so what a release basically, that's one place we can see it. If we also go to Heroku, see if I can get there, Heroku, and if I look at this app, and I see, if I look at the activity off the right here, you see that I deployed, and it says it deployed a version 8, and that's a release version 8. Okay, so the question is, what is a release? Okay, so the general idea here is, and we're going to come back to this later. So once you have your slug, there may be some other things that are kind of your app depends on, right? You have sort of your source code and all the build and all that, but you have environment variables. We'll talk about things called resources. There's other pieces that your app depends on, and the totality of all those together are called a release. So maybe a set of environment variables along with your source code, plus some other things. Again, we'll talk about that later, is what comprises a release. Right now, we're only messing around with essentially the source code and the slugs, right? And that's the only thing that's really changing between releases. But we'll see later on, we can do other things to create new releases, even though our slug stay the same. Okay, so basically, think of it as it's your release is your slug plus some other stuff. Okay. Now, one thing you can do here is just as sort of a side note. So as you do a release and you go to check to see, I guess we can check it right here. I think you can click on this button, Open App, and you see my Hello World 2, right? And I can hit reload and it says Hello World 2. What I can do actually, let's say if I accidentally release my code, right? And I found a mistake. I want to roll it back quickly, right? So you could actually go, if you go under, if I can figure out what button, I think it's under Activity. So here's my release. You can see that I had a previous release version 7. If I click this button, it says, hey, I can roll this back. Okay? And if I push roll back, okay, it releases a new release called version 9, but it's actually the rollback to v7. So if I hit return on this, I should have Hello World again. Okay, so again, that's basically releases and how you can roll them back. Okay, I think that's that. Okay, so the next concept, you think about a release, the next concept is called a stack. So let's see if I can find this here. Heroku stacks. Right. Now, what basically stacks are operating systems, right? This is right here. It's operating system. So when you build your slug, right, which is part of a release, that thing needs to get deployed to something to run, okay? And you can have different operating systems you run it on. Now, it turns out that for the most part, Heroku only has only 2 options today. One is based on Ubuntu 18, called Heroku 18, and one is called, which is the older one called Heroku 16, which is built on top of Ubuntu 16. Separately, again, this is a topic for another section. You could actually, if you wanted to have your own operating system that was not those 2, you could actually create your own Docker container, right? So Docker is a sort of a portable operating system you can think of as, and you can have a very customized operating system that's running, but you have to maintain it yourself. So that's, and again, that's something we'll cover later. Now, how do you see which version of the stack your application is running on? Well, we go back to that same command we've been using. It is Heroku apps info, and you will see, I hope, see stack. Oh, here it is right here. The stack. So this Heroku 18 right here means that this application, right, this release, right, well, application itself is running on the stack of Heroku 18, and which means that release was deployed onto this Heroku 18 OS. Okay, so that's the next concept. It's basically stack, which basically is operating system, 3 options, one of which you can then create your own essentially. Okay, the next concept is called Dino. And that is, so the way we can look at this is, I think the way you can visually see this is, if I look at resources here, so you can see this, right now there's only one Dino running, okay? And it's the one that's I defined in my proc file, right? I said web was the type, or the name of it, and this was the command to actually run. And again, web was a reserved word, means it's a web Dino, which means it can take HTTP traffic on the port specified, the port variable. Okay. So if you had other entries in your proc file, you would have more Dinos listed here. So think of Dinos essentially as the instance of a stack, right? In this case, the Heroku 18, running your release, right? And in particular, it's running a particular command within that release. Because you may, for example, have in that release, you may have multiple processes, meaning you may have a web, a worker, some other worker, you may have a number of these things. So again, dynos are basically, think of them as basically little computers running some bit of one of the processes you've defined in your proc file. Next thing, one thing you can do, and it's not really apparent when you're using free ones like this, is you could actually have more than one instance, one dyno, right, running of a certain type. So for example, let's say you started seeing a lot of load and you need to spin up more of your web dynos, right? The way you can do this, and I'm going to do this, I'm going to actually turn on, I'm going to burn some money here, switch over to a paid dyno. And so now I'm using a $25 per month dyno, right? And what I can do is if I hit this, you can see that I can actually, I'll just double it for now. Just so you know, you only pay prorated, so I'm not like really burning 50 bucks doing this, right? So right now, I actually have technically 2 web dynos, right, running of type, the web type. Okay, this over here changes the performance characteristics of it, so I can have faster dynos essentially, or more memory. Okay, now just to illustrate this, if I go to my logs, if I can figure it out, we can see that when I did this 2 dynos thing, that I can see my app running twice. So let's see, where's my logs at? Overview, run console, view logs. Okay, let's see if I can see it. Right here, right. So this was the last process where I just basically stopped all the one dyno, and then I upped it to running 2 dynos, and you can see this line, app web 1 and web 2. So I actually can have more than one web, and you can see that the console log output is appended with the name of the dyno, web 1 and web 2. So I can see the different outputs. Okay, so that's just illustrating that. Let me turn this back down so I'm not paying before I forget. So I'm going to go back into here. I'm going to change it back to one dyno. Well, I can go to 0, which essentially turns off your service. Okay, I'm going to go back to one dyno, and I'm going to move back to the free one, and boom. And then you'll see now I'm back to 1. And just to round this out, if I was to actually go to my logs, I should see now one now here running. Basically, I stopped the second one, I shut it down, there's only web 1 now running, and there's no web 2. Okay. So that's basically the core concept of dynos. Now, there's a couple key ideas to keep in your mind about dynos, right? One is that the most important one is that they have ephemeral file systems. What that means essentially is you should, outside of the build process where you did your compiling, right, and put it in your slug, everything that's outside of that slug in terms of the file system of that running dyno, you should consider as being tossed, like disposable, that you should not depend on it being there at any given moment. And we'll talk about why that in particular is important. Well, we'll talk about it in a second when we talk about the Dino Manager. But again, it's super important. Don't write to the file system, essentially, and expect it to be there, at any time going forward. So you should be using databases, you should be using Redis, other things to store data, not the file system of your dyno. Also important to know that your dynos are all firewalled off, right? Again, we're talking about the common runtime environment right now, right? So this is this particular things we're talking about. The networking piece in particular is specific to the common runtime. The dyno is completely firewalled off, right? So nothing can come in. Now you can make outbound traffic, but you can't do anything inbound unless it's a web dyno, in which case it can listen on the port that is specified for HTTP traffic. So that's the one piece. And then outside of that, though, you can't have different. You can't have, for example, you can't have different dynos in your application talk amongst themselves in the common runtime environment. They all keep track of their time through a network time protocol, so that you can say the time is going to be pretty much accurate, right? And there are some thread and process limits on your dynos, right? So you can't necessarily go crazy with the number of threads in that. And there's some, but it's pretty generous. But in this case with Node, essentially running single-threaded, right? So that is a single-threaded, single-process application. So it's not terribly relevant for Node. The only other thing specific to web, and then again, this is not really relevant for Node so much, but for a web one in particular, you have about 60 seconds from the time it starts to have the app start listening on the port for HTTP traffic. Again, with Node, it comes up within maybe 30 milliseconds, 50 milliseconds. It's pretty fast, so it's not really a concern in the world of Node. But if you're running some other environment that has a long startup time, it has to be within 30 seconds. It has to connect to the port and start listening for traffic. Okay, and this kind of brings us to the last topic for this video, which is Dino Manager, right? So some of these things that we're talking about being enforced, like 60 seconds to listen, right? There's a process that Heroku manages that sits on top of your app, looking at the statuses of your dynos and then managing them. So that's why it's called a Dino Manager. And the first thing it does that you need to be aware of is that every day the Dino Manager will restart all of your dynos, right? And that's just to help clear out any maybe memory leakage or whatever kind of sort of subtle problems you might have in your code. It also kind of enforces the ephemeral file system. So if you start writing stuff to disk, you will, without notice, you'll be recycled. Now, technically, just so you know, it does actually, when I say without notice, it does give you 30 seconds from the time it wants to recycle it. The Dino Manager will send a SIG-term message to your app, which you could listen for and then maybe clean up after yourself before it shuts down. But just in general, it restarts your app every day. Okay. Another thing it'll do is, again, this is in the common runtime environment. If your memory usage of your app, so if you go to overview, right, your app, where's my overview? I don't have a graph here. Resources. I guess I'm not really using a lot of stuff right now, so I can't get a graph. But if your memory usage is double of what its limit is, it will actually crash. It'll shut down your app and restart it, right? So that's another thing it'll proactively manage. Also, if your app actually crashes, it will automatically restart it, right? But it does it in a sort of an exponential back-off way, where the first time it crashes, it'll immediately restart. And then if you crash a second time, however, it will then wait 20 minutes before it brings it up. And if it crashes again, it delays even. The delay between the restart is even longer, all the way up to 320 minutes, which is what 4 hours? I think it's 4 hours. It's a lot of hours. That's actually more like 5 hours. Whatever, 320 minutes. It's going to basically wait 320 minutes and then try to restart it again. So the way you kind of reset that timeout, that back off, by the way, is you fix the problem that crashed it by releasing a new release, and that resets us back to basically the first status, where on the first reboot, it's immediate. First crash, it immediately reboots. Okay, so again, this was mostly a somewhat meandering walkthrough of some of the core concepts. We talked about regions. We talked about build packs. We talked about slugs. We talked about releases. We talked about stacks, dynos, and Dino Managers. And we kind of used our simple example to walk through those concepts. So I think that's it for this video. Again, this was very high. There's a lot of theory. Hopefully we'll get back to more doing. See you in the next video.